I welcome all of you on platform of YourPedia Education, and as you know, YourPedia has recently launched the NPTEL module for preparation of various exams. You know, NPTEL, which is the platform of learning by IITs. Many IIT professors teach on this particular platform and provide very good lectures, very good content, very good questions. There are videos and then there are assignments, there is a literature, learning materials. So, there are so many things in NPTEL. All of you have already studied NCERT books during your school days. When you used to prepare for entrance exams like JEE, you were knowing that there are so many competitive exam books also, but at the same time there are NCERT books also. The kind of concepts and questions, very precise but very important, were there in NCERT workbooks, and you used to see that NCERT is something which is very important for any entrance exam. They are basics, they are fundamentals. Similar to that, when I started listening to lot of professors, their videos, and I started listening to the content of these professors, and I saw the assignments. The questions actually in the assignments are really very good. Not only you can build up your concepts on the basis of these questions when you solve, we will also keep on telling you that which professor has taken that particular subject, so that if you want to listen to his videos you can do that. Only thing is, for one particular subject, the professor, the way professor is teaching that particular subject is academically, I will say that to develop the concept for learning. Many of you have your own objectives, like clearing GATE exam, engineering services exam, or BARC exam, or ISRO exam. So you have your own objective. Now what we have done is, we have taken those questions from NPTEL assignments which actually may be useful for these competitive exams, and they are really very good concepts, very good questions. Now this series which we have started on YouTube, almost daily you will get one topic on the basis of which some questions will be done. This series will help you to understand, okay, what kind of questions can be there in exams and how you have to approach. We will try to make justification with the concept also. So we will provide you concept, content and questions. Now all these PDFs which we are making, we are collecting the content and material and theory which is important along with questions. This particular thing which will be available on YouTube, that will be available on the website also. So you can take that PDF and you can save it with you, you can keep it with you. So almost every day there will be one lecture or the other, of one subject or the other, you will find it. That will help you to understand, okay, this is the kind of questions which can be asked. Today my lecture is related to surface tension and capillary. So I am taking this topic together, and I will be doing some questions, and I will give you a feel of some kind of questions which can be asked, which I have taken from the NPTEL assignments. So when I was going through the videos, I found the videos of Professor Som and Professor Suman Chakrabarty are good. I referred to the video of Professor Suman Chakrabarty for some concepts, and Professor Som, I have already seen his book also, and it's a nice book written with good concepts. So I was referring to his videos. On the basis of that, we have collected some kind of questions, and before that I give you question. Let me tell you this entire information whichever I have collected from very standard reference material from NPTEL and all. So that is available, you can see that on our website also, you can go and you can find it out. Why I find NPTEL very good content? Because nowadays BARC interviews are going on. There are some intricate concepts which are asked in the interviews also. So our purpose is not to clear GATE exam or written exam of BARC or ISRO or something. Our ultimate objective is to clear interview also, and to eventually pass the entire process. So the kind of questions which are asked in interviews, those kind of concepts are also available in this. You will find that those concepts are also there. Like when we talk about surface tension, everybody talks about surface tension. The most important point which actually we need to understand in surface tension is that this is a fluid property, no doubt, and it is related to cohesive. but it is observed at the interface of two immiscible liquid. So, immiscible liquid is something which is very, very important. It is the tensile stress which act at the interface of two immiscible fluids. So, if I give you surface tension, which of the following is true for the surface tension? Which of the following is true for the fluid property which is surface tension? So, you need to understand it is at the interface. Number one, it is at the, it is number one, it is the tensile, you know, it is the tensile force acting at interface of two immiscible, you know what is the meaning of immiscible fluids. Now, where he can make the difference in choices, he can make the difference in choices. Instead of writing fluids, he may write liquid, but actually it is immiscible fluids, that means liquid and gas, like water and air, it can be like that, and this is acting at the interface only. So, on the basis of that, I can make the answer choices. Also, you should know that it is molecular attraction, cohesion, and dissimilar molecules, unlike molecules, attraction, adhesion. So, when there is an attraction between like molecules, it is called cohesion. Whenever there is a attraction of like molecules, it is called cohesion, and whenever there is a attraction of unlike molecules, like liquid and gas, liquid and solid, it is called adhesion. So, it is the interplay between adhesion and cohesion, but surface tension, because it is a fluid property, so it is because of the cohesive force. So, eventually surface tension is a cohesion. Capillary is basically the interplay of cohesion and adhesion. Adhesion is dissimilar molecules, cohesion is a similar molecule. So, surface tension, as the name shows, is a tension acting on the molecules which are on the surface. So, वो सबसे important point, it is basically immiscible. Now, he has made a diagram, very good diagram here. As you can see, there is a molecule B, and molecule B is under the attractive force of similar molecules and dissimilar molecules. There are similar molecules, there are dissimilar molecules. So, if you see these molecules B, this molecule is also B, that is the similar molecule, cohesion. But then this side there is a molecule A which is of gas, dissimilar molecule. Now, suppose B is under the attraction of these forces also, and B is under the attraction of these forces also. Let us say gas molecule is not in position to attract B that much, so that force will not be strong, and hence eventually the molecules which are on the interface, they will be in the state of stretching, they will be in the state of attraction. So, this kind of attractive force will be existing among the molecules, they will be stretching one another. So, if suppose two boys hold your hands and pull you, pulling means attraction, cohesion means attraction, cohesion means pulling. So, somebody is pulling me this side, somebody is pulling me from this side. Tell me what will happen to me? I will be stretched, I will stretch myself, and that helps, certain things can be kept here. So, certain lightweight bodies, lightweight insects sit on the, when there is a liquid's interface, insect will sit, like mosquitoes and all, you will find they are sitting on the water. So, that is a very thin layer stretching, and on this particular thing they can float, something like that. What you should know is, what is the dimension of surface tension? All of you know what is the dimension. It is a force per unit length or energy per unit area. Typical value of surface tension of water at 20 degrees centigrade is 0.074 Newton per meter. 0.074 Newton per meter. Maybe you can remember this value for your future reference. And because it is at 20 degrees centigrade, that means yes, surface tension decreases with the liquid temperature. As the temperature increases, surface tension decreases because intermolecular cohesive forces decrease. Another very important point is critical temperature of the fluid surface tension becomes 0. That is, at the critical temperature, if you go, what is the surface tension at critical temperature? It becomes 0 because boundaries between the fluids will vanish. So, on the basis of the theory also, you should know some questions can be framed. For the written exam also, Which of the following is true for surface tension? At the critical temperature, surface tension is 0. The surface tension decreases with increase in temperature. Surface tension is because of cohesive force. Surface tension is always when there are two at the interface between two immiscible liquids. So these couple of concepts which we learned, ये points आपके direct exam के लिए, for your exam these will become the good quality questions for you. So just remember these. This particular part you have already done. Excess pressure part you have already done. That means whenever there is a stretching in molecules, the molecules will try to stretch entire fluid into minimum area. And उससे क्या होता है, when the surface will try to minimize the area, because surface tension is surface energy per unit surface area, and surface tension is basically to minimize the surface area. So minimum surface area is that of spherical shape. So in tendency to minimize the area, the liquid molecules or fluid molecules within less area try to collide with one another, and that leads to rise in temperature. So because of surface tension property of the fluid, as we know, surface tension, if I give you the formula of surface tension, this is nothing but this is the surface energy per unit surface area. Now surface energy is sigma into A, and any body is in equilibrium if its energy is minimum. Now sigma is the fluid property, it cannot change. To minimize surface energy, surface area has to be minimum, and minimum surface area is that of spherical shape. Now the surface molecules try to basically minimize the surface area of the body molecules. In the process, the pressure inside rises, and that is called excess pressure. What is the meaning of excess pressure? That means pressure inside is more than pressure outside. Let us say outside pressure is atmospheric pressure. So pressure inside will be more than pressure outside, and that delta P we can calculate. There is a formula you all have done. Delta P, excess pressure into this area, delta P into pi r square surface area is equal to, now surface tension is acting at the surface, that means if this perimeter if I take, then sigma surface tension into perimetric length 2 pi r. So that everybody knows. So excess pressure is coming out to be 2 sigma over r. This is for liquid droplet of the liquid. If it is soap bubble, there are two surfaces. Now because this is the liquid, this side is air. If I give you soap bubble, then there is a air inside also, and this is the liquid. So how many interface do you get in the soap bubble? You get two interface, air liquid, liquid air, two interface, and hence the surface tension force will be double. So if surface tension force is double, excess pressure will be 4 sigma over radius or 8 sigma over d. So for the soap bubble, whatever soap bubble do you see, in that soap bubble excess pressure is 8 times the surface tension over diameter. So these concepts you have done. My purpose is not to to make you understand it. This is not the purpose of these classes. This classes purpose is to make you understand the most important point for the questions, because I am going to take the questions now. So you should know what are the most important points, and then from there we take the questions. So this is the excess pressure in the soap bubble. Now wetting angle, contact angle and wetting angle, that is also you should know how it is to be done. Wetting angle and contact angle, what is the meaning of that? Contact angle is nothing but angle between the tangent which is drawn at the interface of liquid and the surface and the surface. So the common tangent drawn at the meniscus and the common surface between liquid and the surface, that common basically interface, the angle between that is called contact angle. In this case, this is acute angle, this is obtuse angle. As you know, this is mercury, and this is a water. This is spreading is more, wetting is more. So if contact angle is less than 90 degree, wetting or spreading of liquid is more. Less surface tension, more surface tension. Now I want to basically bring new perspective to this thing here. Now let me take this particular diagram. This is the surface, this is the liquid, let us say this is water. Now this is the solid surface, this is the solid surface, this one is liquid and this one is gas. Gas is air. Now we talk about couple of surface tensions here. This is the surface tension, this is a common tangent which I am drawing, this is the angle of contact theta. Now this side is the sigma between S, that is the surface, and gas. This is surface tension between S and liquid, and this is the liquid and gas. So we get three kind of sigmas here. Sigma between liquid and gas, this is the interface between liquid and gas. Surface tension, this is the stretching of this surface. So if you see this molecule here, it is under the three kind of surface tensions or three kind of surface tension forces. Surface tension is nothing but force per unit length. So if I take very small elemental length, if I take a elemental length very small at this particular point where there is a solid, there is a liquid and there is a gas boundaries. Solid is the surface container, let us say glass, liquid is water and gas is air. So between solid and gas, then this is between the solid and liquid, and this is between liquid and gas, and surface tension is because of the molecular attraction. Now if I want to resolve sigma Lg, and as I told you, if I am taking elemental length as unit length, so this will be resolved into forces. So sigma Lg sin theta will be the vertical force, which I am not considering as of now for this analysis. And what will be the horizontal force? Sigma liquid gas cos theta plus sigma SL is equal to sigma Sg. What is cos theta? Cos theta is coming sigma Sg minus sigma SL over sigma Lg. Now see one thing, if sigma Sg is more than sigma SL, something like this, if sigma Sg is more than sigma SL, that means the adhesive force between this solid and this particular molecule here is more than this particular force which is acting on this direction, then obviously spreading will be more. So spreading will be more if Sg is more than SL, then you will get more spreading. But in this case, when theta is more than 90 degree, in this case theta as you can see is more than 90 degree, in that case what happens is this SL is more than this particular G. If SL is more than Sg, then obviously spreading is less and spherical shape will be formed. So this is typically mercury and this is typically liquid, basically surface, that is how we get it. So anyhow, this analysis I will be discussing with you in some another question, but I just wanted to give you a perspective how this all things actually are balanced. So angle of contact, how it decides whether there will be proper spreading or wetting or not, this is how it is decided. I know this equation you can make, just remember that typical values of angle of contact for air water glass interface is 0 degree, and for mercury angle of contact is 140 degree. So angle of contact, if it is less than 90 degree, then wetting of the surface is more, and if it is more than 90 degree, wetting of surface is less. Now we come to the questions. That was a very brief theory which I wanted to provide you. Now we are coming to the questions. So these are the typical NPTEL questions, and as I told you, the moment you start doing NPTEL questions, they are the most enriched source of knowledge for preparation of any competitive exam, I tell you honestly, because I found these questions very good and I found high correlation in NPTEL questions in the assignments and the exams questions which are asked. Read this question. There is a solid cylindrical needle of diameter d of length L and density is also given. It is floating in the liquid of surface tension y. Neglecting the buoyancy and assuming contact angle 0 degree, what will be the maximum diameter of the needle which is able to float in the liquid? So this is the question which is given. Okay, now let us say this is a needle. This is the I am giving you diameter of the needle is given as d. Let us say this is the diameter, length of the needle is given L, and let us say needle is up to this particular depth is in the basically floating in the liquid, let us say. So this part. Now if I divide it into two parts, this part is of the needle is in the liquid. Maybe you can make some sense of this. Now the weight of the needle is going down, but surface tension force is keeping it up. Because what is surface tension? It is an attractive force. So where surface tension acts? Angle of contact. Angle of contact. But because that is 0 degree, so you know, if it is angle of contact, as I told you, this angle of contact between the surface and the liquid. Now if we take that particular component, let us say this is the angle of contact theta, surface and liquid, and then this is the sigma into L, surface tension, and this length is L. So L into sigma into cos theta, acting upward, and one side is this also. So there are two sides. So sigma is the surface tension. So surface tension force is sigma into length, and how much length? So sigma into this particular length, if we are saying that, and then sigma into L into cos theta, this side. And the weight is nothing but, you know, if we take the weight of this entire particular needle, and if we consider that, then we need to balance the two. That is a question. So let me now provide you solution for this. Because theta is given 0 degree, so surface tension force is almost vertical. Theta is given 0 degree. So vertical force balance. So what is the surface tension force? 2 sigma into L into cos theta, cos 0, and pi d square by 4, that is the area, into L, that is the volume, into rho g, that gives me the diameter. That gives me the diameter of this. Right, from there we can directly calculate the value of this. I hope that you understood this question. This is a very simple question, not a difficult question. Yeah. So this way you can calculate the maximum diameter of this particular solid cylindrical needle. Here we are neglecting the, when we are calculating the surface tension, we are only considering the length to be far more than diameter. So I think that is the assumption we are taking here. Length is far more than diameter of this. That is the reason we are taking surface tension force as S or Y into L plus Y into L, 2Y into L, and then we are comparing it to the weight, and that way we are calculating the maximum diameter. Right. Let us go to the next question now. Next question is, you know, all of you have done this expression. All of you have already done this expression of capillary height rise. Read this question. You have to find the expression for capillary height change H. Surface tension is given, angle of contact between two parallel plates which are W apart is also given, and you have to find out the value of H, capillary height rise. W is also given. So suppose I give you small tube, capillary has a small tube, and you have to find out the height rise. This is the angle of contact, you know, theta, and this one is the rise of the height. How do you calculate normally in the capillary tube? You know that. Let us say diameter of the tube is D. You all have done that. So pi d square by 4 into h into rho into g is the weight, and sigma into pi d into cos theta. Sigma is the surface tension, let us say, and pi d is the perimeter, this perimeter at which surface tension is acting, and sigma into pi d will be acting something like on the angle of contact theta, and one component of that is acting vertical cos theta. So from there you used to find what is the value of h, right? 4 sigma. So when you calculate h from here, you get 4 sigma cos theta over rho gd. I hope you remember this value of rise in height for capillary of diameter d. Now in this case we are given basically two parallel plates which are W apart. What will be the weight now? So total liquid will be something like this: H into W into width is, let us say, B. Width is, let us say, B. So this is the volume of the liquid contained here. Volume of the liquid contained into rho into G. That is the weight of the liquid contained. So weight of the liquid contained here was this. In this case, in case of two parallel plates, weight of liquid contained is height, this, W into width, B, volume into rho G, and then surface tension. And the surface tension, as I told you, surface tension is acting this side, but this component of that is sigma into cos theta, and length. What length we are going to take now? We are going to take length B. B is this width. B is this width. So we are going to consider now that B will get cancelled out. So as you see, B will get cancelled out, and this is what we are going to get it. So H is 2 sigma cos theta rho G D, rho G into W. So between two parallel plates. So many students have done capillary rise of formula for this thing, tubes, but they have not done for parallel plates. If there is a capillary formed between parallel plates, what is the formula? Revise this. So as I told you that if questions are given in NPTEL, you have to revise that. They are very good questions. And if values are given now, Y is given for water 0.07 Newton per meter, rho G for water, specific weight, theta is almost 0 for water, W is also given. So what is the rise in height level? So this is a typical gate type question. Find out what is the rise of. And same question can be given when you see that BARC के interview में वो आपको बोलता है, when you go for the interview in BARC, he asks you to go there and drive the expression on the board. This is the kind of question they give you. They give you, can you find out the formula of capillary height rise? You start with the typical formula which you have done in the college, and then you say, okay, now don't take a tube of diameter D. Now you take parallel plates which are separated by distance W, and find out the height rise of capillary H. Width you can assume, B you can assume, because B is going to get cancelled out. From there you can find out the expression for this. Very good question. Now third question is this. There is a soap bubble of diameter D1 which coalesces with another bubble of diameter D2 to form a bigger bubble of diameter D3. Assuming isothermal conditions, isothermal process, find out D3 as a function of D1, D2. So he can give you numerical also in that form, and majority of NPTEL questions, they are not framed as if they will be asked in gate. They are framed for checking your knowledge. So maybe he will not give you answer choices or something like that, but concepts you have to understand. So what is happening is, now what is the question given? There is a soap bubble. You know what is the sigma for excess pressure for soap bubble? Excess pressure for soap bubble is, this is what we found, 8 sigma over radius. Here it is diameter given. So I think this is 8 sigma by R we have just now calculated. So there is a soap bubble. This is another soap bubble, diameter D1, diameter D2. When you mix these two, it becomes diameter D3. Now you have to find out what is D3 in terms of D1, D2. And the concept is, when these two bubbles meet together, what do you think remains constant? Let me ask you, what do you think remains constant? Volume or mass or density? What remains constant? normally mass does not change. This bubble plus this bubble collapse together, mix together. Matter remains same, so mass is going to remain same. That is the concept in this. And isothermal process here is given because air is ideal gas, so isothermal process ke liye mass is not going to change. So let us say the mass after this is formed is M3. So M3 is equal to now M1 plus M2. And how do you write mass? Mass is a density into volume. So density into volume is called mass. So that means we have now, let us say density is rho 1, rho 2, rho 3 and volume is V1, V2. Can you tell me what is the bubble? So sphere 4 by 3 pi r cube, that is sphere, that is the volume of a spherical shape or bubble. In terms of diameter, how can I write this? 4 by 3 pi d cube by 8, it comes out to be pi d cube by 6. So that is the volume of bubble. What is the volume of bubble? Pi d cube by 6. So M1 pi d cube by 6 plus M2 pi d cube by 6 is equal to M3. I hope you understood this. What is ideal gas equation? P is equal to rho RT. Have you done this? Now rho is P over RT. Rho is P over RT. Now understand, in ideal gas equation this is the absolute pressure. Many of you are not even aware what is absolute pressure, and let me give you the idea of that. Pressure can be measured in terms of gauge pressure, it can be measured in terms of absolute pressure. So when you measure the pressure with absolute reference, 0 Pascal reference, it is called absolute pressure. Now atmospheric pressure, as you know, is 10 raised to power 5 Pascal, that is above the 0 Pascal reference. So 0 Pascal reference plus atmospheric pressure. Abhi bubble ke bahar, if I give you a bubble, outside pressure is atmospheric pressure and then there is a pressure inside also, and because of surface tension we know excess pressure is formed. So what is excess pressure? We found the formula of excess pressure as 8 sigma over d. 8 sigma over d for bubble. We found the formula 8 sigma by d, or for that matter we can write 4 sigma by radius. We just derived the formula. So what is the excess pressure formula for bubble? That is 8 sigma by diameter or 4 sigma by r. Sigma is the surface tension, which in this question he is writing as y. Now what is the absolute pressure? Absolute pressure is atmospheric pressure plus delta P. Now see this side, P atmosphere plus 4 sigma by r is the absolute pressure, and absolute pressure over RT, it becomes the density. So what is the density? P over RT. RT gets cancelled out. This is V1, V2, V3. This is P1, P2, P3. And which pressure is this? This is the absolute pressure. How do you calculate absolute pressure? Atmospheric pressure plus excess pressure. And what is excess pressure for bubble? Excess pressure for bubble is 8 sigma by d or 4 sigma by r. This is how we calculate it. I am very sure this question is clear to you. In the GATE exam, he will give you the real values. He will give you the values of d1 is 1 millimeter, d2 is 2 millimeter. Find out d3. The moment you know now, atmospheric pressure will also can be put in terms of that, and atmospheric pressure can also be added. So the moment you put d1, d2, the d3 value can be calculated. So this is also a very good question of coalescing of the bubbles. And now this question is related to data. In fact, you have to memorize it. I will derive this particular expression somewhere in some of the questions. I will derive this expression later on for you, but I think I have solved it in the regular our module, NPTEL module. There was one question, we have done that in detail, but for you, this, please remember, this question can be very important. What is correct expression for capillary length? Capillary height is not capillary length. Don't misunderstand the two things, that is a different thing. So what is the correct expression for capillary length, which represent the length scale at which capillary and gravity effects are equally strong? Length scale. So the answer for that is capillary length is T over rho g under root. What is T? That is the surface tension. Rho is the density, g is the acceleration due to gravity. So this is the capillary length. This is the expression. How this expression has come? I told you I have derived this question, expression somewhere, but as of now, please remember it. I am very sure this question is going to be asked somewhere. What is capillary length? read this document. I have provided it to you. You can read this document. What is capillary length or capillary constant? Capillary length or capillary constant is a length scaling factor that relates the gravity and surface tension. That is the definition of this. But for deriving, I need half an hour. I will derive this expression for you and you will understand what is the meaning of it. But go through this document, read this through this particular document. So the capillary length actually is related to surface tension, and that is how capillary length is equal to surface tension over rho g under root, right. So I think we come to an end of this particular session now. So with this, I think this is our first daily question, NPTEL question based module. You will find one lecture or the other almost every day, and uniqueness about this module is in every lecture you will find good question from NPTEL along with the concept. This entire thing will be provided to you. You go to our website and there you will find the document also. The same document which we are discussing will be provided to you, and this is the part of our detailed NPTEL module, question module, which not only will help you to clear GATE exam, but engineering services written exam, BARC written, BARC interview, because once your concepts are good, concepts are clear, you can clear all the exams. All the very best and keep watching our modules. Thank you.